And another type of graph we can do is a phase diagram. Phase diagrams represent temperature and pressure, and it's a closed system, and they're typically not drawn to scale. A few key points, a few key temperature and pressures will be labeled. Now, some important things we need to look at on the graphs are triple point, where all three phases coexist, and critical point, above which there's no boundary between liquid and vapor. So let's look at a phase diagram. See, there are a few important pressures and a few important temperatures labeled. The solid phase is always going to be on the left. The liquid phase is always a sort of V-shaped region. The gas phase is at the highest temperatures. So this is your boiling. Nope, that's not boiling. Let's try that again. Solid to liquid, this would be your melting. So you can look at a melting point at any pressure. This one here, liquid to gas. This would be your boiling. And this one, solid to gas. Along this line, we would be looking at sublimation. Now, for most substances, this solid to liquid line is a positive slope. From this, we know that solid is more dense than liquid. But let's look at water's phase diagram. Okay, note the negative slope of this solid liquid line. That's because the density of the solid ice is less than liquid water. And on all of these, 1 atm allows us to find the normal melting point and the normal boiling point, the triple point where the three lines come together, and the critical point where there's no boundary between liquid and gas.